Good morning. I get the pleasure and the honor of welcoming you to Star Trek because I got the first session. So, welcome. Welcome to Leak Code Hot Seat. I figured it's early in the morning. We all need to wake up. And what a better way to wake up than just like randomly call on you people and ask you crazy hard questions live in front of everybody. Wait, Mandis? The crowd is angry and confused. Yeah. Oh, sorry. That's the wrong session. But no, seriously, I need to travel this morning, about 4.5 hours by car. So while y'all are enjoying Guardians of the Galaxy later, I'll be driving over South Bend, Indiana. But I really want to thank Jared and all the Star Trek team for letting me go early so I could head out before lunch. So, and thank all of our Star Trek hard workers, volunteers for putting this on. So thank you very much. So it is early. Let's not do any hard coding problems right now. Let's take a journey, not a big as journey as Guardians later, a quieter, more nerdy journey. And I'd like to pause on that for a second. If you're here, you're probably nerdy like myself. Maybe you didn't fit in high school. Maybe you feel like you still don't. I went to high school in the 90s, kind of dating myself. I loved computers. My best friend and I set up a computer in the library and made our own BBS. And if you're of the age of the internet, that's where one computer talked to another. And you could send email and play games and stuff, but it was a very different era. It wasn't glorious. Like software development, it wasn't glorious like it is today. No one wanted to be a software developer. I don't know if it's glorious, but you get the point. And comics, too. I grew up reading comics, mostly DC. So I'm excited to see James Gunn move over there and see what he can do with that, because I haven't been super impressed with the DC movies lately. But I wouldn't have guessed that comics and computers would be so mainstream, right? You shop on the internet. People deliver you food after ordering on an app. So kind of eating the world. So I guess, fellow nerds, it's awesome. We did it. We're here. That's fabulous. But back to our journey. The mystery of the increasing AWS bill. So if we're going to have a mystery, we need some ingredients, right? We're going to need a detective. That's not a detective. That's me. A bit about myself. My name's Tim LeMaster. I'm a principal engineer at Pangea Money Transfer. I was previously an engineering manager at Root Insurance. Some of my duties at Pangea include keeping an eye on our AWS infrastructure. How's it running? How's it scaling? But also cost. Previously at Root, I led our telematics team. Root collects data on how you drive by using your smartphone and uploads that to S3, and then also responsible for processing all that. So kind of in the early days, we were responsible for a lot of our AWS and infrastructure growth, constantly stressing that out and stressing out our DevOps managers also. Got about 28 years of software engineering experience, dating myself again. That includes COBOL all the way back. I did about 4 years of COBOL development, saw the rise of the internet, wrote my first server-side HTML and Perl, moved over to Java, found web services, found how much I love back-end development, and scaling, servers, all that kind of stuff. I did get a little jealous there for a little while of all the cool user interfaces people were making. And I don't really like web development, so when iOS came out, I did a long stretch of iOS development, developing Objective-C first and then Swift, but then finally coming back to the back end, Ruby at Root. Love Ruby, that's kind of my go-to, and .NET at Pangea. And now tons of work on AWS infrastructure and infrastructure as code, where I really have a passion for infrastructure, and especially infrastructure as code, and responsibly growing and scaling our systems. So our detective, our Star-Lord, he can't be our detective, right? No, he's the hero of the movie. That can't be right. Jeff Bezos? No. Oh, I get it. This is Oz-Lord. Yeah, Korath, I get it. That's a bad joke. Bad joke. Of course, we need the actual mystery, the case, the problem, the conundrum, the reason we're here today, besides Guardians of the Galaxy later. I've seen it, and no spoilers. It's fantastic. I laughed, I cried. But back to the mystery. Why are we here? Destiny's Child? That surely can't be right. No, bills, bills, bills. This is the mystery of the increasing AWS bill. So in the end, the mystery is, where are these increasing bills coming from, right? Where's all this extra cost coming from? What's happening? Like all good mystery stories, we're going to look for clues, we're going to chase some red herrings, and spoiler alert, ultimately we're going to crack the case. So how did we get involved in this case? What was the first clue, right? How do we get on this trail? In short, what's the history of this mystery? I joined Pangea in February of 2022. A project was underway to convert from .NET Framework to .NET Core. If you're not familiar, .NET Framework runs on Windows. .NET Core runs on Linux, Docker, anything. And there was a project underway to move to that. And that wasn't done to reduce costs. It was done to, adopt to the new .NET Core framework and to get off the Windows servers. These were running on EC2 servers at the time, building our own images, putting those out there. Wanted to get on Docker, Linux, ECS, ephemeral servers, deploy, get new servers. So it wasn't a cost exercise, but a just modernization. So in March of 2022, we moved the traffic over via our load balancer, a little bit of traffic onto the new, most of it onto the old. Some of you have probably done this dance. Eventually got happy with it, right? And all the traffic was cut over. So in April 2022, we shut off the EC2 servers entirely. And I got busy with some other projects and whatnot, and I hadn't really looked into our AWS Bill too much. But in July of 2022, I did. I wanted to see what was happening, right? In March and April, we had run double our infrastructure, right? We had the EC2 servers running, we had the ECS tasks running. And what happened after that? Did it shoot way up and drop back down? So I went to take a look. I don't want to explain this graph here for a second if it's not obvious. So this is our AWS scaled cost. It's scaled to March of 2022, so that's 100%. You can see in April it dips a little bit, but then in May it goes up. June dips from May, but still up, and then July we're up here at like 112%. Right? That's a increase of a lot over just a few span of the months, and it didn't really align to our business growth. So I decided to look into this issue. So I started looking at this data in AWS Cost Explorer to understand the cause of the increases from April 2022 to July 2022. Cost Explorer allows you to break down costs by AWS cost categories. Those map loosely to their various services. AWS has tons of services, so you don't have a category for every service, but you have large categories like RDS, EC2, whatever. Hopefully you know what you're using and what those categories are on, but there's a ton of them. So what I noticed is that our RDS cost category was growing quickly, and all the other categories kind of had modest to no increases, which makes sense because RDS is by far our largest cost category. RDS is Amazon's managed relational database service. Our application runs on RDS using a provision Aurora MySQL cluster to support our production application. And at the time, we really had nothing else running on RDS in this account. So we know the cost driver is RDS, but what's specifically happening in this database? This graph is just like the other one. There's many like it in the slide. So 100% there on March of 2022, and all the way up to 123-ish on July of 2022. So I dug into the RDS data for April. I charted the whole month on a daily basis, and I found something interesting around the middle of the month. On April 20th, the RDS cost was 63% higher than it was on April 18th, and on April 19th, it was 18% higher than April 18th. So to me, that suggested we deployed something midday on April 19th that was very costly. I went through our Git PR and commit history and found a change we deployed to production on April 19th, 2022. As a side note, we kind of changed our deployment process since then. We now create a Jira release. We take all of our tickets that are going with that release and put them in there. We post that release to Slack and then release that once we're done. So instead of digging through Git history, kind of have a release and dates that go together or scroll through Slack. I love digging through Git, but a little more efficient. So this change, excuse me, this change had a new query that was running once a minute or about 86,400 times a day. This was a very heavy query, and it wasn't critical to our application. It was kind of still a POC or a work in progress. Oh, red herring number one. I did say there was going to be red herrings, and I guess this would be a short talk if we already found the issue, but that number one's kind of really worrying me. Let's press on. Let's see what happened. So on July 28th of 2022, we shut down this query. Like I said, it wasn't critical to our application, so we were able to just turn it off, so it happened very fast. We saw a slight decline on RDS costs, and then a slight increase, and kind of back to normal, right? Overall, you know, this change had little to no impact. Yeah, sad Star-Lord. I mean, Oz-Lord. Okay, let's be sad for a moment, but we got to get back to work, right? These costs are driving us crazy. So, if you remember, I started looking at this of February, March 22 based on the EC2, ECS work we were doing. But now the problem I was looking into was beyond the scope of that, right? It wasn't related to this project. I needed to expand my search, right? What if this problem existed long before April or March timeframe? Turns out it did. Expanding a search back more than a year, so this is AWS scaled costs from May of 2021 till July of 2022, reveals it was pretty stable from May 2021 up until around October, November 2021. And then it kind of takes off. You know, we're approaching double the cost out here in July of 2022 compared to May of 2021. Definitely not associated with the business growth. So this raises the question, is RDS even the right place to be looking? So we go back to Cost Explorer, breaking down the cost by cost categories, and doing that over the course of a year, and we see that, yeah, RDS is still the cost driver. Same sort of graph here, 100% on May 2021, growth exploding. This is actually, you know, triple out here at July of 2022. And all the other cost categories had modest to no increases. But why is this happening? We need a new tool. We need to get out of Cost Explorer. We need to look at other metrics. CloudWatch. CloudWatch to the rescue, right? Many metrics. If you are familiar with CloudWatch, it's an AWS service that collects logs, metrics, and event data. You can search through this data, graph, create dashboards, creates alarms, and there's a ton of metrics in here. I took a snapshot the other day. I think there's almost 11,000 metrics shown here in our production dashboard. And CloudWatch retains metric data for 15 months at a 1-hour granularity. Finer grains are available for shorter periods of time, but in this case, 1 hour or even daily is great for this work. So there's a ton of CloudWatch metrics. There's a ton of RDS metrics in CloudWatch, but we quickly find one that's very interesting. We see a change in this volume read IOPS around October of 2021. And then we see this huge spike on November 16th. And then it kind of stays at the new level, and that growth, just continues off to the right here out into July of 2022. It even got a little bit steeper somewhere around March of 2022, so this problem's not going away, and it's only going to get worse. It's got to be solved. Yeah, I couldn't agree more, Rocket. This jump is super frustrating. We definitely need to find out what's going on, find it at the source, attack it with everything we have. We started with Cost Explorer. We broke down by cost category to find RDS. We use CloudWatch metrics to find a jump in this volume read IOPS. Let's go into performance insights to see if we have queries that are much heavier than the others. If you aren't familiar with performance insights, it's a tool for RDS that allows you to investigate what's causing load on your databases. It's lightweight. We run it all the time on our production databases. You do have to turn it on, and you do pay for it. I think it retains data for 7 days by default. You can pay for more. But I highly recommend you turn this on if you haven't. We run it all the time. It's great. So it has counter metrics like rows read per second, queries ran, connections, threads, active transactions, much, much more. It can show you your data sliced by different criteria. That's the graph here on the screen. I don't have a graph from this event. We only had the metrics for 7 days, so didn't capture a graph at the time. Can't reproduce it. But this graph shows wait events, and you can scale this to show your max vCPU or not. This doesn't. This only goes up to 1. If this was showing the max, these would be very, very low, and that would go up to like 16. And it can also show you the top 25 SQL queries and where they're spending their time. See, I knew it. Red herring number 2. If there's going to be a red herring number 1, there's going to be a red herring number 2. So let's go see how we failed to crack the case again. Using performance insights, we found 6 queries that were spending large amounts of time in what RDS called sending data. This name is, in my opinion, very misleading, because if you look up the definition in the AWS docs, it includes, and I quote, reading and processing rows, completing a full read of all data from a query, reading data from a table, index, or the work of the storage procedure, sorting, grouping, or ordering data. It's like everything, right? That's everything a database does. Writing to net is the state in which the data is actually being sent back to the client. So I don't know why this is called sending data. But AWS does helpfully suggest that queries spending lots of times in sending data are most likely inefficient, do not have proper indexes, or if all your queries are spending a lot of time here, your database is probably under-provisioned, not enough RAM or something. And that's what we found for these 6 queries. They were either doing a full table scan or using an index that still resulted in millions of rows. We could do a whole talk on query optimization. Someone might be doing one here later today. But I was just going to go through our methodologies here briefly. So what we did was use performance insights to capture SQL samples of those bad queries. Underneath those 25 queries, they're kind of grouped. You can expand those and actually get the actual SQL ran with the parameters and everything. So you can copy that and drop that right in to analyze it. And that's what we wanted to do. I took a snapshot of our production database, because I'm not going to play around with queries on our actual database. And I spun up a snapshot in this new database, dropped these queries into my SQL client, and use explain to see the query plan. And that's where we get these rows scanned from. So we can see 1.3 million rows, almost a million rows, 5.5 million rows, 2.6 million rows being scanned to run these queries. That's not great. So using that query plan to see what indexes it was and was not able to use, looking at the queries, looking at the tables and indexes it has, we determine some new indexes to create. So we add the new indexes to the snapshot database, run explain again, and look for improvements, right? So in this case, the first one, 23, 23, these were like the same index, very similar queries, 852, 1, 1, 1. Most excellent, right? We see a massive decline in the rows scanned and a massive decline in the execution. So awesome. We're going to ship this to our production database. Yeah, you know, everyone loves order of magnitude improvements. But Thor, we are still in red herring number 2. Let's not get too excited, Picard. Yeah, RDS scaled costs. We put this out on August 2nd, and basically nothing happened. Yep, sad Picard, face palming. It's red herring number 2. I think we all saw that coming. But all that work, all that digging, almost zero impact. What in the world's going on here? We tackled the 6 most impactful expenses queries on our database and barely moved the needle. It feels like we're completely off track, something we're not doing right. I think we need to head back to CloudWatt metrics and really understand what that metric is trying to tell us. So volume read IOPS, back to that. What is the precise definition of volume read IOPS? So don't like to read totally, but I am going to read this. It is important. Amazon says the number of build, read I/O operations from a cluster volume within a 5-minute interval. Build, read operations are calculated at the cluster volume level, aggregated from all instances in the Aurora DB cluster, and then reported at 5-minute intervals. Aggregated for all instances in the cluster. That's pretty interesting. Do we have more than one instance in our cluster? Yeah, we do. We've got a failover, right? We've got a write instance. We've got a read instance waiting there to take over if the write instance failed. But we also have a place to run expensive queries that monitor our application. So if volume read IOPS is for the entire cluster, is there a similar metric that would be per instance? Turns out, yeah. AWS defines storage network throughput as the amount of network throughput received from and sent to the Aurora storage subsystem by each instance in the Aurora MySQL database cluster. This is a measure of network traffic, but it's to and from the storage subsystem, not to and from your client application. So it really is a good measure or proxy for how much reading and writing is happening on Aurora and disk and those volume read IOPS. And you can see the shape of this orange line is very similar to the shape of this blue line after the spike. It's really a really good proxy for what's happening there. And there's actually 2 lines here. I don't know if you can see them. There's an orange one. That's our read replica. And there's a green one that's down there at the very, very bottom on the, just laying on the x-axis, right? So if our RDS cost is growing and build IOPS is the driver of that cost, it's pretty apparent that anything we do to the write instance isn't going to make any impact, right? We could drive massive improvements in that green line, and that orange line would just totally dominate at, 2 times the order of magnitude. So the real culprit, the read replica. But where and why? But hooray, no more red herrings. Heading back to performance insights, this time to the read replica. Like I said, turn on performance insights, even on your read replicas. It'll come in handy. We discover 3 queries that are running very frequently, and are very, very inefficient. We followed the same process here. We took our snapshot, left that database up. You can shut it down for a while, but when you're exploring something, leave your tools in place. So if you get off track, need to backtrack, need to come back to something, it's still there waiting for you. Taking a snapshot and spinning up a new instance actually takes quite a while. So back to our snapshot, grabbed samples of these queries and dropped them into my SQL client and ran explain. And we found query number 1, 15 million rows. Query 2 and 3, 114 million rows. These queries were doing full table scans on our largest table. That is not great. So searching through our code base, we find a project called Lambda RDS Alerts. This project was a series of lambdas. Each one is a query which produces a metric and is scheduled to run the lambda frequently, and then there's a cloud watch on that metric. These were some compliance alerts that were scanning our database for transfers that were not compliant with our rules. An earlier version of this, actually super early in the company's history as I dug into this, was actually running on someone's laptop through a VPN connection to the database and running similar queries. That stopped working at one point, so these lambdas were quickly put together to run these on AWS, but hadn't really been monitored and paid attention to over time. And they were running longer than 15 minutes, and the Lambda was timing out, and they weren't even producing the metric any longer. Fortunately, we had a project in flight that was almost just about ready to ship, and among other things, was going to replace these alerts using an event-driven system. So instead of scanning our entire database looking for issues every hour or 15 minutes, however these ran, every transfer that comes through will scan as it happens and raise alerts right there in real time. Since these alerts were not working anyway, we disabled the 3 lambdas associated with those queries, and you can see what happened to the volume read IOPS. I don't have the storage network graph, throughput graph at that time, but had a very, very similar drop. So there is a bit of unsolved mystery with this based on the way we solved it, right? We shut down these lambdas. They weren't working. We didn't really need them. But there is kind of like a dangling plot thread here, right? What happened on November 11th, 2021? As we solved the problem, I didn't fully dig into this. I do have a theory. MySQL has what's called the buffer pool. And the buffer pool permits frequently used data to be accessed directly from memory. As you recall, our cost was from the storage subsystem of Aurora. So prior to November 11th, if our data was mostly fitting into memory, we wouldn't even be going to disk that often, even though we were scanning all these millions of rows, right? We didn't suddenly get 114 million rows on the 11th. What I think happened is we kind of spilled out of memory, and now these queries had to go to the subsystem, the disk system, every time they ran. It seems likely it's a dangling plot head, but that's my theory. Sometimes stories have dangling plot lines. But what happened? So May 2021 to September 2022, this is our RDS scaled costs. RDS costs are just 10% higher in September 2022 from May of 2021. Okay, AWS scaled costs, our entire bill from May 2021 to September of 2022. Again, just 10% higher. And another way to say this is 16 months later, our bill was just 10% higher. a far cry from that double, almost double we had been at in July of 2022. Yeah, okay, celebratory memes. You can come back. Yep, Elf, Thor, Picard, even you. Loved your third season. Glad to have you back next gen. So what tools did we need in our tool belt to solve this problem? AWS Cost Explorer. You can analyze your AWS costs, monthly, daily, hourly, filter by the AWS services, see which ones are costing you the most money. Find out, what's happening with your bill. Where's all this money going? AWS CloudWatch, all the metrics, right? Not always easy to find what you want, not always easy to find the precise definition of the metric, which, as we saw, was critically important. But once you do that, you can analyze a problem, create a dashboard, set an alarm on that problem for the future if it comes back. Just be proactive. Finally, performance insights. You have to enable this in your RDS settings. As I said before, default retention is a week. You can pay for up to 24 months of retention. See what's going on in your database. See where it's waiting, what the wait events are. Look up the precise definitions of those, very non-obvious. See your heavy SQL queries and the waits they're encountering. Get the full SQL queries that you can actually just drop right into a MySQL client or whatever database you're using and run explain, whatever tool you have to analyze query plans, and check things out. The twist. Every mystery's got to have a twist. We cracked the case. We saw the celebratory memes. We reviewed the tools we used to solve the problem. What's left? Well, about, 17, 20 minutes. But what else really left? Lessons. We use those tools. We chase red herrings. We solve the problem. We ultimately return the cost to the previous level. Sure. But the real story of this mystery is one of failure and what we learn from those failures. MCU, Marvel Cinematic Universe, no, just heavy product placement. I'll probably never be able to give this talk again. Funny story is I came up with the following points before the MCU thing kind of just happened, so here they are. M for monitor. Monitor the things you care about. Many people have said you can only improve what you measure, but equally true, you can only prevent disasters on things that you measure. You can only prevent them from getting worse if you're measuring and watching them. You probably monitor your application response time, error rates, crash rates, many, many things. If you're like us, you have lots of alarms, dashboards, monitoring what's happening in production. And why do you do that? When things go wrong, costs you customers. They leave, they get frustrated, and in turn, it costs you money. But out of control infrastructure can also burn through a surprising amount of money. AWS has billing alerts you can turn on. Once you turn them on, you can create CloudWatch alarms on these things. They also have a service called cost anomaly detection. And this was a problem for a long time, right? October 2021 to July, August 2022. Had we known about this problem, we could have acted then instead of in July. This one thing would have saved the company tens of thousands of dollars. So failure, learn from failure. When you're building, modifying things you care about, how and what you're monitoring should be one of your inputs. How can this go wrong? What signals can we send to ourselves when it does? Think about this in every aspect, every project that you do. I bet you your future self will thank you, and hopefully your peers and leadership will thank you too. Cast, C for cast. Cast a wide net. If you remember, we started looking at this data from March 22 forward because that's when the .NET migration shipped. That's what I was originally interested in. I was originally interested in what happened with our EC2 and ECS costs and stumbled along this RDS cost issue. But I didn't immediately expand my search radius to include all data possible. If I had, we wouldn't have chased red herring number 1 for very long. I also didn't suspect the read replica. I just assumed if we had an issue, it would be on the right DB. I failed to include all the suspects in my lineup. Had I done this, we wouldn't have chased red herring number 2 for very long. So do not hold on to previous assumptions when the situation changes. Ask yourself, with this new information, are previous decisions, are assumptions I've made, are invalid? Do they need to be revisited? Understand. Understand what you don't know. Aurora was new to me. I'd used RDS before, but not Aurora. And I didn't take the time to understand what that volume read IOPS metrics truly meant. Had I dug into this definition earlier, might have occurred to me to look at the read and write instances separately. Additionally, I had only worked at the company, what just happened? I had only worked at the company since February of 2022. I should have taken more time to understand what was out there, what's all running against our databases. Talk to more people, talk to other engineers, talk to my leadership, talk to my business partners. What's out there? What could be happening that I don't even have any ideas out there? So when digging into a problem or using a new technology, integrating with a new system, take time to understand what you don't know. We all get in a hurry. We want to get things done. We want to make progress. We want to impress people. But often in the long run, that actually ends up costing us time, money, effort. So truly understand what you're looking into. So that's the MCU. Monitor, cast, and understand. But think is the most important lesson. Above all, think about the problem. Remember these slides? SAD, Oslord, face palming Picard. Every time we found an issue, we stopped thinking about the problem and we started thinking about solutions to those issues. We didn't know that issue was the problem. Don't get me wrong. These issues were very much worth solving, right? That high frequency query was causing other far more important work to run much slower than it would have, frustrating our customers, slowing their transfers down. Those 6 poorly performing queries were jamming up our workers, causing that work to run slowly, costing us more money. But I wish we had done these things after finding the large problem, the big cost, right? For 2 reasons. And honestly, I think the second one is probably more important than the first, even though it doesn't seem that way at first. The first one, we solved the major issue sooner. Got our costs back down to the previous level. Everybody would have been happy. Awesome. Those celebratory memes, high fives all around. Yeah, let's get back to it. But what's interesting is these slides are one of sadness. But we fixed an issue, right? We found something and we fixed it, but it wasn't what we were looking on to. So instead of celebrating 3 wins, we actually celebrated 1 win and were disappointed twice. Had we tackled these in the right order, we would have celebrated 3 wins, right? We would have solved the major issue, and then we could have said, oh, by the way, we found some other smaller problems along the way. Let's go solve those. Celebrate those. Instead, every time we pushed out a change, we were disappointed. And staying motivated and energized at work is critically important. So This is a quote from Albert Einstein. If I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about solutions. I love this quote, but completely failed to do it during this investigation, right? So be like Albert Einstein. You don't have to be one of the greatest scientific minds of all times to focus on the problem. If you enjoyed this, and I hope you did, I write about all sorts of software and technology topics at devnops.net. It's completely free, no ads, just me writing a few times a month. This talk all evolved out of a post there. I've got other stories there, including one where I almost ruined Christmas, no joke, and the obligatory ChatGPT article. But the reason this is here is the name, and it's germane to this talk. So the name is devnops.net, which is obviously a play on DevOps, but that middle part is NOPS, also a play on no operation. So CPUs have a command, a no operation, that doesn't do anything, but costs time in your CPU. Humans are like this, I think. When we're learning, when we're struggling, things are going slower than we want them to. We're looking at our peers and we're seeing seemingly they're more successful than are. We're trying to be that mythical 10x developer, but things are going slow, we're frustrated, work is hard. That's the times we're learning, right? If you want to be that peer that everyone looks up to, that mythical 10x developer, these times are important. That's when you're soaking up new information. It's taking time because you don't know yet. And the way you have those moments where you do feel like you're on top of the world are backed by all these times that you don't feel on top of the world. So give yourself a little grace, right? Recognize this is happening, and you don't have to embrace it, you don't have to celebrate it, but give yourself a break. If someone else is doing this, give them a break. If you're in leadership and someone's trying really hard, things are going a little slower than you want, but you know they're putting in the effort, you know they're trying to make a difference, give them a little grace. This is really, really important. We've got some time for some questions, either here in person or via Discord. If not here or there, feel free to ask me later. I do have to travel, but I can be around for a little bit. Sure. Yeah, anything? Anybody? Oh, sorry, spotlight. Yeah. Yeah. Sorry, I can't see. So the question was, when we were looking at the cost, did we consider data transfer? I think the short answer is no, I didn't consider that directly, but what I did is I looked at all the metrics in CloudWatch, and I tried to find one that was increasing. And what I found was that volume read IOPS that suddenly spiked and stayed up, and map that back to our RDS costs. So I was pretty, at that point, finally, I was pretty sure that was the driver of the cost. Does that answer your question? Awesome. Anyone else? Sorry, I'll step aside and see if I can see. Oh, absolutely. Very good question. Yeah, if you haven't moved to the cloud, I mentioned those billing alerts. Cloud can be a lot more expensive than you think. It's great, don't get me wrong. I wouldn't do it any other way, but especially on like And whether it's AWS or Google's or Azure, they all have these managed services that scale really, really well, as we saw from this volume read IOPS and this storage network throughput, scaled way beyond what we needed it to do, and we were just paying for that. So, I mean, monitor your bill first and foremost. Monitor all the managed services that you're using. Hopefully they have some sort of anomaly detection. A lot of clouds have that now, so if something suddenly changes, even if you're not monitoring specifically for that, you can get alerts. But on the database front, monitor your CPU, memory usage. On your compute front, same sort of deal. Monitor your CPU, your memory usage. Monitor your response times. However you can do that, either like in our case, we use API Gateway. You can see response times from that. We use New Relic in our application, which actually instruments the application, and we can see response times happening in our Docker containers. Monitor, obviously, for non-200 HTTP codes, if it's like an API, if you're getting a lot of 500s. And if you're using something like API Gateway or a load balancer, you also need to monitor HTTP errors there, because what will happen on a load balancer is if your API compute is struggling, your load balancer or API Gateway will get 500s, will be returning 500s from that because it's not getting any answers from your server. So you'll see average response times starting to like shoot through the roof and a lot of 500s returning. You're on your way to an outage. So that's something super critical to monitor if it's like an API. What else? So I can think off the top of my head. But yeah, however you deploy your application, whether it's serverless, EC2, ECS, whatever, I'm not as familiar with Google and Azure, whatever they have and you're using, monitor those things. I would say critically, errors, response times, CPU and memory, if it makes sense, if it's not like a serverless thing. Yeah, it's a very good question. Anything else? Well, thank you. I really appreciate. In conclusion, monitor the things you care about, cast a wide net, understand what you don't know, and above all else, thank you and thank you, me included. That's all I've got. Thank you so much. I really appreciate you spending a little bit of your Stir Trek with me, and I hope you enjoy the rest of your day. Thanks.